Welcome everyone. In this video I'm going to show you how to display different kind of numbers on a DWIN display, and this will include integer numbers and floating point numbers which are received by the display, and I will also show you how to create a number on your display using a keypad and then send it to the serial port. And I will use an Arduino to generate the numbers that I'm going to send to the display, and also to capture the numbers which I'm generating on the display and sending it to the serial port. So it's not only that I show you how to configure and set up a display that can do these things like sending and receiving numbers, but I also show you how to catch those numbers or how to send the numbers to the display. So it will be a fully enclosed system. So now we are looking at the main display of the DWIN editor, and we can start with the configuration here. And I have explained how to configure the display, so I go a speed run here only just to get through the basics. So first you have to open the word bank generating link, which can be found at the DGAS config tool part. And now it is open. We have to somehow fit these letters in their corresponding frames. And what I would suggest here is that first you select some kind of font. You select it as usual. And after that, you here at the characters, you select something wide, a G, W, or M or something. Let's go for W. And then you have to adjust these four parameters until you can make all these letters here fit to their corresponding frame. You can see that instead of a W, now you see a single U or V. So we have to change the scale. And what I do here is that I'm just simply making it narrower. But you can see that the edges are serrated here. And that is because the ratio of the letters is not the best. So I would decrease the vertical scale a bit, like this, and now you can see that everything fits. And once this is done, you have to click on this create button, and then you can see that the progress bar is going here on and on. So now each font with the different sizes is being built. So we wait for this, and then we proceed after this is done. So now it's finished, we press OK, and we can close this tool. So the next step, what we have to do is the ICL generator, and that is here. So now we have the ICL tool, and what we have to do here is that we have to load in the pages for the display that we are going to create. So here we have the option called Select Pictures, so we click on it, and then our folder comes up where we store our pictures. And to have everything in the same place, I'm already using my project's DWIN set folder, because actually the files that you kind of compile will be stored here. So then I just select the pictures which I'm going to use for this tutorial, and then I press open. And now I have the pictures loaded, and you have to be careful about two things which are visible here in this field, or these fields, that the file numbers or the file names should start with two numbers. So the first page should be 00, the second page should be 01, and so on and so on. And the second thing that you have to be careful about is the resolution. So when you create the page picture, always make sure that you have the same picture resolution as your display's resolution. I'm using this display, which has 480 × 800 resolution, and I'm using it in a portrait mode, so that's what we have. And then I have to click the Generate ICL button here, and now this display pops up, and you can see that I have already saved my ICL file. So actually you have to save the ICL file as 32. That has to be the name, and this ICL file is the package file which stores the pages. So you just name it to 32.icl, but here it's already showing the extension of the file. So just 32, and then you press save, and then the 32.icl will be in your DWIN set folder, DWIN underscore set, and full capital letters. So this is done. So now we returned to this page, and while we are here, we can actually navigate to the CFG edit page. So I do that now. And now we have arrived to this configuration part. And here I have to emphasize two very important things. One is this guy here, touch sensitive variable changes update. For some reason, this is on non-auto by default. And if you leave it like this, whatever you set up in your software to upload something to the serial port, when you touch a button or release a button or do something, it will not happen, because in the main config file, which we are creating in this page, it is not allowed. So we have to change that to auto. So that will allow the code or whatever is behind the display, that will allow the code to send out things to the serial port. So then it has to be auto. And then another thing is the baud rate, which is now this 115200. But I have noticed that if you are using software serial on an Arduino, then this baud rate is not really good. Sometimes you get garbage data or you don't get data at all, so it should be 9600. And then once these settings are set, you might want to also turn off the touch sound, because anytime you touch the display it gives a beeping sound, and that might be annoying. So then everything is done, and you can go to the new CFG button down here. So this display comes up, and you already can see that I have saved this CFG already, but it has to be named as T5L-CFG.cfg. And once again, the extension is already here, so it just becomes T5L-CFG. And then it's done. So now we have everything done, and everything is in the DWIN underscore set folder. So these things have to be copied on an SD card. And the SD card has to be maximum 16 gigabytes. I have noticed that if I try the 32 gigabytes, it is not working because of the file system we have to use. It's a FAT file system and not NTFS, and that doesn't really like the 32 gig SD card. So grab another SD card, which is smaller, and use the following command, which I printed on the display in the command prompt. So you just press the start menu and enter CMD, and then this window comes up. So you have the CMD, and then you enter the command which is on the display, and you change the letter of the drive that you have. So always double check if you are using the same drive letter as you have for the SD card, and then you just do the formatting. And after you have the formatting done, then you can just simply copy over the DWIN set folder with its content. So on the root folder of the SD card, there has to be a DWIN underscore set folder. And under that you have these CFG files, which I printed on the display. And also the font file is that must be there. So now you know everything about generating fonts, generating the page file, the package file for it, and generating the config file for the display. And you also know how to format the SD card that you will use to upload the code to the display. So now I can show you the coding part or assembling the display part. So we are opening the touch and display config tab, and you can see that I already have the controls on the display. But one thing before you actually see your display is that you have to go to the left hand side here, and under the images view tab you have to click this plus button. And once you click this button, as you can see, the browser comes up, the file browser, and then you can load in the page files as JPEG or whatever image files, and then they will show up in the list. on the left side. And then you can see that we can jump between the pages. And then we can associate the controls with these page files. So you can see that we have a few controls here. So first we have the received integer up here. And then that is configured in a very easy way. So if you look at the right hand side, you can see that I chose VP address as 1000. And this will be the VP address which we have to use when we send the serial command to the display. And then, yeah, the show color is just the color of the letters or numbers for now. The word bank ID is just the font ID that we generated now, and it's 0 because we have just the one file, which is at the 0 index. Font size, yeah, I just adjusted the font size until I'm satisfied with the size, how it fits into this rounded rectangle. And then alignment is left, but you can see that I also moved this thing around, so it's basically center aligned. But yeah, you can see that you have all these options, but I leave it at left. And then these two options, I'm not using it. And here comes the fun part, the variable type. So here I chose integer 2 bytes, and you have to keep in mind that this has a limited range. You can see it on the display, what is the range. And if you know that you are going to print numbers above or below this range, then you have to choose the long int instead of the integer. But for this example, I'm just using the 2 bytes because I will print the raw data from the AD converter, and I'm using a 10-bit AD converter, the built-in AD converter of the Arduino, so it's enough to use 2 bytes. And then the integer digits is 4, because I'm going to show 4 integer digits. And the decimal digits is not applicable here because it's an integer. There are no decimal digits, so we skip that. And variable unit length, I also kept it at 0, and show unit is also kept empty. You can play around with these and see how it works. And obviously initial value is just some dummy value, which you can see it's just basically the maximum value that we can receive from the AD converter. And then now comes the next part, which is a float. And this will be very funny because obviously I'm checking other tutorials just to see how other people progress with their stuff and what is available on the internet. So I'm not doing something which is done 1000 times, but I'm trying to do something which is like, let's say, more advanced content or explained in a better way. And no one has done floats so far. So whenever I saw like people build this general humidity and temperature sensor combo as a weather station, but they always use integers for representing the temperature. However, the thermometer or the humidity sensor could show you at least one extra decimal digit. But it seems that people don't really understand, or I don't know, I'm not criticizing here anyone or anything, but for some reason people are avoiding printing float. And I will show you why, because it's not that straightforward, but I did it. So you will know how to print a float. And here I will just convert this integer into the voltage value, which is read by the AD converter. I'm just using a potentiometer, and that will be printed here. So then the VP address on the right hand side here is 1100, and that's enough, far enough away from the VP address of the integer. And then the rest of the values you can just read it from the display, but it's just, yeah, it's up to you how colorful fonts you want to use and how large fonts you want to use and so on. But what is different here is that I'm using the 4 bytes float. That has a bit larger range, as you can see, as compared to the integer. And for me, it's more than enough for anything. And then the integer digits here is unnecessarily 4, but since I'm using Arduino, the maximum voltage will be like 5 volts or slightly below it. So I would need just one integer digit, but here I'm using 4, just for fun. And the decimal digits, that's the more important stuff. So integer is whatever on the left-hand side of the decimal point. So yeah, the integers. And then On the right hand side we have the decimal digits, so that is the point something something something, and I'm using 4 digits, and that is just for the demonstration's sake. And you can see that I have already written some initial value, and that is shown here on the display. So now these have been quite simple, because this display and this display also data variable display, so you can just reach them from the text show menu, and you have the data variable display. So then you draw it wherever you want and then configure the things. But then how to enter a number? Of course we need to have a keypad, which is like here. So first we have to be able to open the keypad. So I go to this, so I have this keypad button here, and I placed my let's say trigger area over the keypad button, and this trigger area is a ASCII text input, so you can reach it from the touch control, and we have the ASCII text input. And then here, this is the important things where we really need to pay attention to the config file. So we have to check this data uploading or data auto uploading here. Otherwise, it will not upload the data that you typed in the keypad. And then I put this on the VP address 2000, and then I set in the text length. And the input mode is re-input, which means that whenever you reopen the keypad, the previous value will disappear and you start with a blank value. And then the font width and height, it's not really necessary here, but yeah, I kept it this large. You will see it why, but yeah, it's again up to your own design how to change it, as well as the cursor color and the font color can be changed. I kept this unchecked, the upload value as typing. And then here we have to do kind of a jump. So what I'm doing now is we don't care about this input display area right now, but I go to the display mode, that's direct display. So whatever you type in, that will appear on the screen. And then the keyboard location, so basically the location of this page, that will be a new page. So that means other pages. So when you press on this stuff here, a new page will appear. And then we have the keyboard setting here. And for some reason my stuff disappeared, but I can do this. So you click on this keyboard setting, and then this window comes up, and obviously you have to select your keyboard. So I press OK. And then this guy comes up. So now we want to display whatever we want to display. So I just want, I don't want to reprint the whole page just for fun. So I just select this area here, and then I press OK. And now you can see that this thing showed up here. So now we can set the show location. And as you can see, I cut the same image. So these are basically the same background image, but with different content. So what I do is I go here, and then I check the content of this keyboard area box. And you can see that the X is 0 and the Y of the starting point where I cut the image is 206. So actually I just copy that over here and set it. So then, yeah, I could change it here as well. I just move it there. Somewhere it was 206. Yeah, something like this. So then it is set. And now I jump back to the input display area. So I set, and then I enlarge this a bit. And I have to click on this displayed keyboard. And you can see that the keyboard showed up from this part. So then the input display area is the area where you want to store or display the typed in numbers. So I just go and select this area because that's why I made it to display the numbers here. So that's done, and I just press OK. And this is done so far. So now we are satisfied with this part. So the ASCII text input is done. And now I create this text display because I'm cheating a little bit and I'm actually typing the numbers as text. So we have this text input, and in this text input, which is under the text show text display, it's a typo here, so I just dragged a box over this area at the bottom. So that's done. So let's select this display, go to the right side, and this has to have the same VP address as the keypad. They have to share the same memory area because that's how the values are passed in between the two things. So that's how the ASCII text input control passes the values to this text box after you pressed the buttons and sent the number to the display, basically. So then they share the same address, and then text color is up to you, but then it's important to have the encoding mode at 0x02 equals GBK. Otherwise you get garbage text. So let's leave it like that. Again, alignment is up to you. Text length, I haven't said probably, but when you are talking about length, here at the keypad, the text length is mentioned or defined in word units. One word is 2 bytes, but here in the text box itself, this length is in bytes. So as a rule of thumb, you use twice as long text length in the text box as you use it in this text input. Font IDs are not mandatory here. And then these X and Y direction lattice numbers are set to 48. So that's about this page. So now I open the second page here, and you can see that I have already placed the controls. So I'm not going to do it again, so I just show you that. I went to the touch control and I selected this basic touch module, and then you see it's a yellow rectangle. So I just fitted over this area properly over the button, you can see. And then I just created one at a time, and then I copy pasted it over the other letters and the numbers. And then I just chose a different size for the clear and enter buttons. So then I just show you 1 or 2 buttons, but basically you create the button, put it over the corresponding area, and then you go to the right side. And the only thing that you have to do is that you have the key value 0x field here, and there's this checkbox, full QWER keyboard, you check it, and then this set button shows up. So click on it, and then this guy comes up, and we have number 1 here, so I just click on the keyboard or key code number 1. And then the window disappears, and now we have this number in this box, which corresponds to the number 1. And then you just keep going with all of these things. And then once you have all the numbers and the minus symbol and the decimal point, then you just have the clear and enter. And the clear here is the backspace, just to make it clear. So how I did it, that's also available from here. So check this checkbox, click on the set button, you have this window, and then you have these functional key code buttons. So you just click the backspace, and then it's associated with the backspace code. And then for the enter, you click it, again click the checkbox, set button is pressed, and then here the enter is not the enter because that is like the line break, but you have to have the return as a command, and then it's done. So this is done. So now actually you can go to the file, save your project first of all, and then you can click on the generate, and then that generates the rest of the files, which have to be in the set folder, DWIN_set. And then you can upload the code to your DWIN display. So now I guess I can show you this in action. So I set up a camera which will record the display at the same time while I show you how this thing reacts. So I prepare those things, and then we will see how this thing works. So here is the display, and you can see it is already running. So then you can see it on the top part that we are printing almost always the same integer right here, and that is the AD conversion value in like raw bits or raw data. And then under it, right under it, that's directly the float number. So that is the voltage value from this conversion. And then here now, for now at least, we have a raw data which is just the initial value of the display that I set in the editor, but we will change it with the keypad. But just to show you that this thing works is that now I'm turning a potentiometer, and then now you see that we are roughly halfway, so it reads 2.40 something watts, and of course I can change this. And you can see that the update is happening relatively slowly because I changed the update rate to half a second, so it's just a choice by me. But you can see that I change the potentiometer and then the values change. Now I turned it to the bottom, so yeah. So it works. But obviously this is just sending the values to the display, so it's nothing extraordinary. But we want to send something to the Arduino. So now I place the windows in a way that you can see everything. And yeah, the only thing I have to do is I have to press the keypad button. So now you see that we receive the keypad. And just to give some challenging stuff to this display, I enter a negative floating point number. So we can use the negative sign, you can see it. And then I enter some number, and then the decimal point, and another number. And then I press enter. And as you can see, they basically match. Because of how the floating point works, you can see that the 0.0004 became 0.00039. But if you round it up, it will be 4, so it doesn't matter. But since I'm sending 4 digits after the decimal point, but I'm printing, you will see it, 5 decimal digits, we always have this kind of funny behavior. But obviously I can do something like this and send it. So now you can see that they match, because now there is no garbage at the last digit, because I'm printing 5 digits. So when you have the serial print, you can see it soon, then you can set up how many digits you want to use and how many digits you want to display. And I chose 5 because I want a lot of digits. But of course, if you print something under that, like now I'm printing just 2 digits, then yeah, now we are lucky. But sometimes these other digits can have a small discrepancy, like we had it here. So the minus 485.6214, which we sent from the display, became 62139. So yeah, that's that. But yeah, you can see that the display works and it does what it has to do. So just I turn the potentiometer once again, and let's send the last number. So 0.86217 or 4. Let's make it 7. So it's the same value, as you can see, same on the display and same here. So now I explain you how to make an Arduino code to deal with all these things. So here we are. I'm using the software serial, and I'm using the pin number 9 and pin number 8. And for just myself, as a reminder, because I'm using white and the yellow cable, I just kept a reminder for myself which is which. And then I'm using the A0 pin as the analog pin, so that is the pin which is reading the output of a potentiometer. And then I create the instance of the software serial here. And now I create the data holding or carrying units. So I have the incoming data character array with 100 items in it, which will store my characters which I'm receiving from the display. And then we have the text string, because we have to send the data as a string, so that's what I chose. And then I have a received float array named array, because this will be the character array which holds the, let's say, digits or bytes which we extract from the serial message. And then, of course, this array items will be converted into a floating point number, which is then printed on the serial terminal. So we have a float for that. And then I store the analog reading, so the ADC raw data, in this value or variable. And then the conversion of this value will end up being a float, because it's a floating point number. It will be 2.569 whatever. And I have this ADC timer, because I want to update the display and do the readings in a non-blocking way. So I will just count for a certain time, and when the time is elapsed, I do the stuff, and then I restart the timer. So then we can jump to the setup, and we have the original serial of the Arduino. So this is the USB part, and 9600 baud rate, and then just some random message. Now, since we are printing numbers, we will print this. And then the software serial will look like this. And I put a notice here that we should use the 9600 with Arduino and software serial. If you have a native serial microcontroller, which for example has multiple, like an STM32, then you can use other baud rates probably, but here I just use it like this. I set up the TX and RX pins and then wait for half a second. And then here we have two methods or functions. One is fetching the text, and another is doing the reading from the ADC. And I also put the printing on the serial port inside this function. So let's see, since it's right under here, how this read ADC works. So it works in the same way as my typical timer-based functions. So if the current value of the millis minus the ADC timer, so the less time we saved a value of the millis into this variable, is larger than 500 milliseconds, then we enter here. And then what happens here is that I update the value of the analog reading, and I'm just doing a very dirty way here. I should average several readings, but this is just a demonstration. You can tweak the code for your own taste. So I just save an analog reading from my analog pin A0 into this variable. And then I just use this formula to convert the raw bits into voltage value. So I'm using the resolution here. I divide the analog reading with the resolution. So the number of steps that we have in the 10-bit scale, or maybe this should be 1024, it doesn't matter right now. And then I multiply it by the reference voltage, so that is like 5 volts. And then what I do is I'm sending an integer number. There is a separate function for that, you will see it. And then that will send the analog reading, basically. You can see the argument. And then another also takes an argument, which is sending the float. And here I update the ADC timer. So then the timer restarts, basically, because when this returns, this code returns to the if again, then the difference between the millis read here and the millis stored in the ADC timer will be tiny. So then this if will not run. It will not be triggered. So then this keeps going on until the millis increased enough to have 500 milliseconds difference between the last time we updated the values of the millis. And this is how you can go and do non-blocking code. You should never use delays. You should use this kind of method. So this is the smart way. Then I jump to the send numbers because that's more interesting. Integer numbers is very simple. We have the headers, then we know the lengths, 2 plus 1 plus 2, and I put the explanation here. So the VP address, this is just 1 byte. 2 bytes. I'm reading the wrong line, so the VP address is these 2 bytes. And then I have the write command, which is the hexadecimal 82. And then I have 2 other bytes because of the high byte and low byte of the number that we want to send, the integer number. So that is split up to high byte and low byte, and it's being passed to the display, and that's all. But how to send float value? Here the trick comes, and I hope that people will take this from me, and then they will apply it, and they will, start using the display properly. So we take the float value as the argument, and then we don't do any fancy stuff here, and we also have a fixed length because we know how many bytes we send. But this, since I copy-pasted, is not correct, so this is the length of the float, which is like 4 bytes, and you will see why 4 bytes. Then write command, and then we are writing to the VP address of 1100, and that is sent by 2 bytes. And then I create a hex array which stores 4 bytes. You can see 4. And then I have this tiny function. I took it from the internet, but you will see how it works. I explain it. But this guy takes a floating point value, which we pass to the function by an argument, and then it converts it into hex, which is stored in the hex array. This guy just we declared here. And then, once we have this, we have to flip the order of the endianness of this created hex. So we start with the third byte, and basically third byte, and second byte, first byte, and 0th byte. And we pass it to the display. And then the display will perfectly show you the floating point number, as you could see it on my example. But then what does this float to hex do? So now we can look at this float to hex function, and it's a bit twisted logic, but you just copy it, write it down yourself, and you will see how it works. So it takes a floating point number, and it takes also this byte pointer hex as an argument. And then we create a pointer again here, f_byte name, and then we apply this reinterpret cast byte star with the end f. I don't know how to read these things, but what this does is that this f byte becomes a pointer to the value of the f. And then once that's done, we can do a copy of the memory where we take the f_byte as the source of the information, which is just the pointer to the floating point number, and then we copy it into the hex. So I'm probably wrong because I'm not very good at programming, but how this works is that this pointer will point at the area where the float or f is stored, and then due to this reinterpret cast conversion or casting, whenever we look at this thing, or when the code looks at it, for example, when it copies the memories, then it sees the float as an array of bytes. And that's what we do here. But if I'm explaining it very badly, please, if you are very good with these things, this is too advanced to me, just correct me in the comments. So please feel free. That's why we are here, to learn. But yeah, in the mem CPY, we just take the content of the f byte, copy it over in the hex, and we have 4 bytes to copy. So that's done. And then we basically arrive to here, where you see the highlighted text is 4 bytes. And then we flipped the order of the bytes. So instead of 0, 1, 2, 3, we have 3, 2, 1, 0. And that's done. That's all. So we just sent these things, and we are good to go. And then I want to show you this fetch text. If you check my previous video where I showed you how to send and receive strings, this is the same. So this is the cheating part. I just added a little bit of things. But what happens here is that if there is a serial data available coming from the DWIN serial port, which is the serial port for the display, I start this starting point for the buffer array. So I declare a counter basically here. And then while we have data on the serial port, then we read the data byte by byte. So I have this incoming byte, which is taking 1 byte from the serial port. And then I wait for a bit, 2 milliseconds. And then I pass the value of the incoming byte to the item in the incoming data. And then I increase the counter. And then I do this all over again until I run out of data to be read. So yeah. And then when that's done, the code progresses towards the bottom of the display. And then we look for this specific position on the incoming data, because we know where is the VP command, which can be either 0x83 when it's reading, and that's what is interesting for us, or it can be 82 when it is writing, when we are sending something to the display. So here, when this condition is fulfilled, we enter this part. And again, another trick is that we know how the structure of the bytes that is coming from the display look like, and we just count the number of bytes, and we know exactly when the message should start that we should process. So I set the counter for that to 7, because I know that from the 7th item I will start to have useful data. And then I declare again another counter which should start from 0, because I cannot have the same counter for the 2 arrays here, because one array starts from the 7th and the other has to start from the 0. And yes, this could have been probably k minus 7, because then this will be the 0, and then when this becomes 8, this will be 1, and so on. But I feel safer to just do this, another variable. It's more readable for me, but you can do it however you want. So then, while we don't reach the end character, the terminating character, I just keep copying the values from the incoming data into the received float array. So that's our floating point number. And then I do an increment and start over and over. And then we have a very easy work here. So the received float, which is a floating point number, is constructed from the array of characters, which is our float at the end. And that is just done with this A2F function. So the A2F takes the character array, or byte array for now, and then it converts it into a float. And here is the issue what I showed you. So I first print this number just to show us what is happening. And then here I print the value, received float, with 5 decimal digits. And then here sometimes the stuff can become confused. If you want to print just 3 decimals, but you print on 5, so the last 2 decimals can be garbage. And then I just zero out both arrays. So when they receive new data, the arrays which receive the data are clean and they don't contain any values. So that's that. And then as you can see, we don't have any more functions, because the first was the fetch text, and that's what we explained here. And then the rest was the read ADC, which also contains the send int number and the send float number functions, which I also explained. So with this, the video is done. So please go to my website, and link is in the description, because I also wrote an article about this. So if you don't like me talking for 40 minutes or something, then you just go to my website and read it at your own pace. I put there some pictures and wrote down most of the things step by step, so you can follow that as a tutorial as well, and then build your own display. And if you like this kind of content, please also consider to become my supporter on Patreon, because that helps me a lot, and it allows me to buy more stuff and create more videos. So then it's a win-win situation. And also I put an affiliate link in my website where you can buy these kind of displays. So if you use that affiliate link, you can support me and it doesn't cost you any money. So feel free to do that. So I hope that this video was useful to you. I hope you learned something and see you in the next video.